All right, so I know the last video is a little bit longer. Let's see if we can make this one a little shorter, right? Not that you want it shorter, right? Okay, so we're going to kind of ignore the directions for this one. We're not doing this obviously in a group setting. So we're going to do 1 through 6. We're not rolling a die to figure out which one we're doing. Excuse me. So we have an algebraic representation. That's our coordinate notation. And then we want to talk about what the transformation is. And we want to, again, be specific. Okay, we're dealing with translations, reflections, rotations. So looking at this here, okay, look at our coordinate notation. What's happening? What are we doing when xy goes to x plus 10, y plus 5? Okay, when you see something like this, you need to think translation. That's a transformation, but then we want to be specific. So this plus 10 here, we're adding 10 onto x. X is our x-axis, it's our left to right movement. So we'll say a translation of 10 to the right, and, okay, here's our y, we're adding 5 to it. Y is our up and down movement. Since it's plus 5, we're going to go 5 up. Okay, so not only do we have the translation, so we have the transformation listed, we're specifically saying what it's doing. Okay, so look at this one here. Xy goes to negative xy. Okay, this is where it's helpful to have your notes of all the different rules we've done. But it's also helpful to kind of think it so you're not just flipping through your notes all the time. Notice if we had the coordinate plane here and we had a point, let's say it's right here, right? We're making our x value negative. So if this is 5, it becomes negative 5. But our y isn't changing at all. What we're doing is we're just reflecting it. So it's a reflection. That's the transformation. And then we're going to be specific and we're going to say it's a reflection over what axis is the up and down one? The y one. Okay, so again, it's helpful to have your notes of this stuff, but it's also helpful to kind of be able to think it through. All right, right here. We're in notation. Let's say we're at the point right here, right? 6. Notice, I need to undo that. Okay, so we're at this point right here. Our x value is staying the same. So if this is at 2, nope, I'm sorry. This is at negative 2. It's staying the same, so we're still at negative 2. But our y value, let's say this was 6, is jumping down here to a negative 6. Okay? Sorry. Draw little pictures, try not to get confused. But notice our x value isn't changing, but our y value is becoming its opposite. So that's going to be a reflection again, but this time over our x-axis. All right. Now this is when we get into some switching around. So notice when it's reflection over the x-axis or y-axis, our x and y's don't move positions. They just become opposites. But when we get into rotations, you're going to notice xy is going to go to a y negative x, right? It's going to switch around a little bit. So I totally get that this is a little bit more confusing. So pick a point. Let's say, like, just pick a point. If you can't find, or go to your rotation notes and figure that out too. We can totally do that. So let's just say we had the point 1, 3. I just made that up. Here's 1, 1, 2, 3. Okay? And so that goes to, we're going to switch them around. 3 and 1. But this 1 here becomes its opposite. 3, negative 1. Okay, so from here to here, it looks like we did a rotation, 90 degrees, right? Because we're only worried about the increments of 90. And then this direction here is clockwise. But remember, the other way we could have thought about it is to go all the way around like this. 90, 180, 270. Or you could say that this was 270 degrees counterclockwise. They go together, if you spell them correctly. Okay. Yay. We recognize this one, right? Translation. We're subtracting 2 of our x, so that means we're going left 2. And we're subtracting 1 off our y, so that means we're going down 1. And in my rush, I'm struggling to even write a W. Okay. All right, and again, this one. Now, this one looks like it should be a reflection. Remember, I said the X and Y don't change. But if they both change, so again, if I'm at that 1, 3, and it becomes -1, -3, watch what happens. 1, 3, -1, -3. Notice that we're actually rotating 180 degrees. So it's a rotation, 180 degrees, but then it can be clockwise or counterclockwise. It's the same. All right. The more you deal with that, the easier it will get. Okay. So just keep kind of working through and using your notes. One last example here. So again, we're not using a paper spinner. We're just going to go through all of them. So starting with A prime right here. Point A, -9, -3, is translated 4 left and 2 down. Okay. I'm just going to use I'll use my summary as some scratch paper. If I'm going 4 left, that's x minus 4, and 2 down, that's y minus 2. So if I put in the point -3, -9, that's going to be -9 minus 4 and -3 minus 2. So if you can just plug that even into a calculator, -9 minus 4 or plus a -4 is going to be -13. -3 minus 2 or plus a -2 is going to be a -5. So our point here is going to be -13, -5. Point B is reflected over the x-axis. All right. So remember, if we're reflecting over the x-axis, all we're doing is changing the y to its opposite. So this is going, xy goes to, x stays the same, y becomes its opposite. Okay? So, -5, 5 goes to -5, stays the same, and the opposite of 5 is a -5. So this is -5, -5. Okay? Again, that chord notation is helpful. You have to think less. Point C here is rotated 180 degrees clockwise. Right here, 180 degrees. Remember, we're just going to take our x value, make it opposite, and our y value, make it opposite. Well, our opposite of 7 is a -7. Our opposite of 6 is a -6. D, if it's reflected over the y-axis, reflected over the y, we make our x value opposite. So I'm going to just -x, y stays the same, and we're reflecting over the y-axis. We're not changing that y. So the opposite of -8 is going to be a +8, and y stays the same, so it's going to say -1. All right, one more. Rotated 90 degrees clockwise. Do we have that up there? 90 degrees clockwise. Very good. Y, -x. Okay, so this is x and this is y. Our y is going to come first. So that's going to be -4. And whatever our x is, we're taking the opposite. Well, the opposite of 2 is a -2. Okay. All right, guys, this can get confusing. I get it, because you're dealing with different rotations, and then you throw in all the coordinate notations. So my advice, the more you write down, the easier. Write these things down. Don't try to do it in your head so much, because it can get confusing. And as always, the more you work with it, the easier it'll get.